Hello, Science fam. We're going to finish up worksheet number 2 of Lewis dot diagrams, and hopefully you're feeling more and more confident. H2O, we know we can just call that water, though covalent-wise, you can call it dihydrogen monoxide if you wanted to, but most people really just call it water. If we start looking at how many valence electrons water has total to work with, each hydrogen has 1, and oxygen has 6 for a total of 8 valence electrons. Oxygen's the oddball, so it's going to go in the middle. And we're going to do a single bond to each hydrogen, right? Because hydrogens only want to hold 2 electrons to be completely stable. That would leave 2 lone pairs on oxygen. And in the end, since oxygen has 8 around it and each hydrogen has 2 like it wants, that ends up being exactly what we need for our Lewis dot diagram. So it's a single bond to each hydrogen, and oxygen has 2 lone pairs on it. Either way you write this is perfectly fine, right? The next one is N2. By the way, nitrogen naturally bonds with itself, so you don't even need to call it dinitrogen. You wouldn't know that at first unless we learned about that, but we just call N2 nitrogen. But each nitrogen, because it's group 15, has 5 valence electrons. So if we do a single bond between the nitrogens and we count up so that everybody has 8, we have 2, 4, 6, 8, 10, 12, 14 electrons. But nitrogen only has 10 to work with. So let's think about that. We have 14 electrons and we only can use 10. So if we did a double bond, that would take 14 electrons and make it 12, right? Because every time you make a double or triple bond, it takes 2 electrons away from the total count. So 14 double bond makes it 12. So 12 with a double bond turned to a triple bond would have 2 less and make it 10. So I am going to guess that if we do a triple bond, 1, 2, 3, that'll give 6 between each nitrogen, and that means they'll each have a lone pair. And there you go. Each nitrogen has 8, and we're only using 10 electrons like we should. So if you wanted to draw that out with the bonds with the dashes, a triple bond would look like that. But nice, pretty straightforward. The next one, CH4, you could call that carbon tetrahydride. The common name for it is also methane. That's natural gas. That's what we burn in our houses, most of us, for our furnace. But I've got 1 carbon and 4 hydrogens, so I'm running out of room, but that's okay. 1, 2, 3, 4. Each carbon has 4 valence electrons, and each hydrogen has 1. That's a total of 8 valence electrons. I think this one, you see where this is going. Carbon's going to be in the middle, and each hydrogen only wants 2 to bond. Well, that's 2, 4, 6, 8. So methane's nice. You end up with a single bond to each hydrogen. Awesome. Lewis dot diagram for that one is complete. All right, made some room here. 1 carbon, 4 fluorines. That would be carbon. 4 is tetra, right? And fluorine turns to fluoride. So carbon, tetrafluoride. Awesome. 1 carbon, 4 fluorines. Excuse me. Each carbon has 4. Each fluorine has 7, right? Carbon's in group 14, so it has 4 valence electrons. Fluorine's in group 17. It has 7 valence electrons. When you add that all up, what's that? 28 plus 4 is 32. All right, keep in mind, 8 times 4 is 32. So if we put carbon in the middle, and each fluorine has a single bond and is holding 8 electrons, carbon's going to be full with the 4 single bonds. Each fluorine will have 3 lone pairs. But remember, if each fluorine is touching 8 electrons, 8 times 4 is 32. So we end up getting exactly what we need for our Lewis dot diagram. If you wanted to draw it with the dashes for single bonds, all right, which, by the way, remember, you don't have to. You can leave the dots for the Lewis dot diagram. But it would look like that. 6 electrons around each fluorine, or what we call 3 lone pairs of electrons. But all right, now that we've gone through 2 full worksheets, if you watched all 4 videos, the part 1 and part 2 of ionic compounds, worksheets 1 and 2, hopefully you're getting a solid understanding of what we're trying for. It's like a puzzle. Everything's trying to get 8 valence electrons except for hydrogen, and you can only use the certain amount of electrons you're given because valence electrons are the ones that are involved with bonding. Remember, covalent bonds are sharing valence electrons so that they stay together and become more stable. All right, nice job, science fam. Hope this helped. Hope you're feeling good, and we can continue to work on this to master this concept.